Hi folks, thanks to be here for this talk about accessing your Kubernetes pods. I'm Nicolas Fränkel. I've been working a long time in IT, in technical roles at first, developer, team lead, architect, and now I'm a developer advocate for Apache API 6. If you are there, I believe you are familiar with Kubernetes, and especially you are familiar with the pod object. And basically a pod object is just like a group of containers that are supposed to run together. Throughout this talk, I will try to do some demo when it's feasible. And so I will use a Kubernetes cluster consisting of 2 nodes. Because I don't want to depend on the cloud, I have set everything on my machine. And let's start right now. So I'm using Kubernetes in Docker. I'm using Docker Desktop, obviously. And I have a simple cluster here, as I mentioned, like 2 worker nodes and the control plane. So it takes a bit of time to install everything, but it's going to be quite fast. And if not, I will just speed up the time. And now it's done, and we can start working. I will be using the Nginx image, and because of I need to preload the image. So this is quite easily done. Now I have already in my local registry, I just need to upload it to and it's done as well. Finally, because I'm super lazy, I don't want to type kubectl every time, though most of the time I will just copy paste, so I will alias it like this. So here I can get pods easily. So let's deploy our first pod like this. For this, I will create a deployment and we can check the pods are there. Yes, I have a single pod. It's deployed on a single node and everything is working as expected. Now let's try some question. What's the IP of our pod? So let's ask. So here I'm asking Kubernetes what pod is assigned to this pod. But we can also ask the pod itself, or not the pod, but Nginx. What's your IP? So here I'm trying another way. I'm getting into the pod, into the Nginx pod, and I'm asking, hey, what's your IP? And fortunately, I have the same answer. So it's like 10, 244, 22. And I'm very happy, but we cannot do much better. At this point, we cannot access the pod from outside the Kubernetes cluster. It's worse than that because in Kubernetes, pods, they come and they go. They might go because it's not responding anymore, and because Kubernetes is self-healing, it will kill the pods and spawn a new one because we are under a deployment. It might go because there isn't enough resources and it needs to make space, and then it just kills the pods. And for whatever reason, the pods are not stable. They are just cattle, not pets. So let's try to do it manually. Let's just kill the pod. And because it's managed by deployment, we expect a new pod to spin up. So we have killed the pods. And now if we get the pods, we see that there is a new pod that has spinned up. So we are happy. We still have 1 pod. There is, however, a big issue. If we ask the pod about its IP, it's not the same one. So previously it was 2.2 and this one is 1.2. And it makes sense. It's a new object. It has been removed. So the IP has not been recycled. It has created a new IP. So if you rely on this IP to access the pods, whether from outside the cluster or inside the cluster, it's not feasible. So we should somehow need a mechanism to have a stable IP address regardless of the life cycle of the pods underneath. And that's the goal of the service object. The service object will create a stable IP, and this stable IP you can rely on. So it will look something like that. It's irrelevant of the nodes, and instead of like getting to the pod IP, you will get to the service IP, and it's up to Kubernetes internal mechanism to, every time the pod is killed and a new one spins up, to bind this new IP with the service IP, so that every time you try to access the service IP, it will forward you to the pod. At the moment, I'm still using the command line. At some point, I will start to use manifest, but so far, I'm fine with that. So now I have exposed the deployment. So now we can check the service. And here I have the Nginx service, and it has a stable IP. However, at this point, we still cannot access the service or the nodes from outside the cluster. There is no way we can access this 1096 whatever. We need to dive further. So let's delete everything and start from scratch again, this time through a manifest. And here is my manifest. So I have a deployment just like before, but now it's manifested in YAML. I have like one replica of one pod that contains a single container, Nginx, in the version that I uploaded previously. And here, the trick is how I can mount some configuration. I will use the configuration to display the IP. So here, when I ping Nginx, it will at the root, of course, it will return to 00, and it will give me its host name, which is what I want, and also the server address, but that's not relevant. And here I have the service that I previously, again, exposed through the command line. Now I've created explicitly. And we can see here there is something called the not port. So let's apply this manifest and check how it works. Now we can check that the service has been created, get SVC. We can check that the pods has been created. And now, at this stage, we are able to call the service, which will forward the call to the pod, outside from the cluster because of this. Because here we are exposing the port. So if we curl local hosts 3800, we finally get access to the pods. And we can see here, it's the IP of the pods. If we kill the pods, and we curl again, we have a new IP, but as for us, we are still using the same service and the same port, so nothing has changed from the point of view of the client. You might have noticed that I'm using a Mac, and for this reason we need a little trick, because we don't have the exact same implementation as in a regular Unix machine. In a regular Unix machine, a container is nothing more than just an isolated process. That for this reason here, I need to expose through kind a port forward. So this is this word here. I'm like, every time I call like whatever on the port 3800, it will forward it to the internal virtual machine of Docker. So that's just the kind of special trick that I need to do in order to make it work on my machine. Otherwise, if you are using a regular Unix or Linux machine, then you don't need this kind of stuff. As I mentioned in the beginning, I have 2 nodes. And here is, regardless of the node I'm actually going to, because they have internally like the different addresses, I will be forwarded to the service. As I mentioned before, the service is not relevant to any node. And the service itself, we forward it to the pods. Now, if we deploy a new instance of the pods, by default, kind will make it so that one of the pod will be on one node and the other pod will be on the other nodes. So we will scale our deployment to 2 replicas. Kind will move each of them to a different node, and let's see what happens if we repeatedly call the service. So now if I get the pods, I have 2 pods, and we can see that they both are deployed on a dedicated node. So perhaps I can make it a bit smaller, like this. Here we see there is kind worker and kind worker 2. So they are like deployed to different nodes. And now, as I mentioned, let's repeatedly call them 10 times. And you see that despite having no balancing, explicit load balancing, there is some kind of load balancing anyway. If I make different calls, they will get somehow load balanced, or at least randomly dispatched, or dispatch according to any algorithm to different pods every time, to different nodes. And all that's the fun part, is because the next object is called load balancer. But as I've shown you, you don't need to have a load balancer to do load balancing. The idea behind load balancer was for Kubernetes to allow cloud providers to provide additional services that were not defined in the spec. So here, because I'm not using a cloud provider, I will be using a load balancing mechanism called metal LB, because it works on the bare metal. However, it should work as any regular load balancer because it's the same spec. So the first thing to do is I will remove the service, and afterwards I will need to apply some metal LB magic. For that, I will install the manifest that install the CRDs, the custom resource definitions. And here it had installed a couple of things that are, again, not very interesting because I don't want to delve into the implementation. At this moment, now I'm able to deploy new spec load balancer on my bare metal machine. So yeah, the condition was met. Here I need to do some inspection because depending from run to run, I might get different IP addresses. So I need to check that the configuration, my next configuration, is like relevant. And it seems to be so. If I look at the, sorry, not this one, this is like 172.18. Yes, this is correct. So now we can start applying the stuff. So we apply this configuration. This configuration is not related to load balancer in general. It's related to metal LB. This is what's necessary. So let's do it according to the documentation. And now we have created specific object. Now we can apply the regular load balancing. So before we had a service of type node port that allowed us to offer like outside access. Now we have a service of type load balancer, but you will see that it's very similar. We still have a node port. So let's apply this. And now that it has been applied, we can do the same trick as before. We can repeatedly call the service and check what happens. And we've got the same results. So here we don't use load balancer to use any cloud provider specific feature. We are just using the regular Metal LB load balancer, and well, it load balances, but as I've shown you before, the node port load balance as well. So there is no other benefit, just to make sure that it works as expected. Now we are at a crossroads because so far all our pods were the same. It was just an Nginx that told, hey, my IP is whatever. But at some point, and it's like the evolution of the internet, we need to have different pods. And once you have different pods but a single point of entry, you need to have some routing. And none of the previous objects are able to do routing. So for this, we have the Ingress object. And Ingress object is able to do some routing. The idea is that the Ingress provides an abstraction, just like the load balancer did, and then you have a couple of implementations. So here I have several Ingress controller implementation. I'm working on the Apache API6 one, but here are others. Those are the ones that you can install on your local Kubernetes cluster, so no cloud-specific one. Just a couple of words on Apache API6. It's an Apache project, as its name implies, meaning it's open source, that it will always be there for you. There won't be any change of license. It's built on top of Nginx. So Nginx, that I have used before, is a very robust reverse proxy, like mature one. The problem of Nginx is that if you want to change the configuration dynamically, it's, let's say, I wouldn't say it's not possible, but it's very, very hard. Like, because it was incepted at a time where it was not an issue to turn something off and on again. So every time you need to change the configuration, the easiest way to do it is to just switch it off and on. And in general, you don't want to have this kind of downtime in modern systems. So for that, there is a layer called OpenResty, and it's a Lua layer that allows you to change the configuration dynamically while keeping everything up, like hot changes of configuration. But on top of that, you have Apache API6, and it allows to have like a structured way to configure everything, namely through plugins. So that's what I will be using in the demo, but most of it you won't see like Apache API6 specific stuff, only when I tell it. The idea is to show you how an Ingress controller works and to see the limits. So an Ingress controller is much more involved. So in my demo, I will have two pods, and now they are different. One of them will be known as left, the other will be known as right. And I want to direct a request and ping or access a specific pod, left or right, depending on something. So the idea is the following. I will first enter a node. The node will direct me to the service of the API6 gateway. The API6 gateway will direct me to the Ingress controller, which is a pod itself. Then the Ingress controller will understand somehow that I want to access, for example, the left pod. It will direct me to the left service, and then the left service will forward me to the left pod. So it's let's say the flow of the requests in an Ingress controller is much more complex than what we have seen before. And here it's only for the left. I should have something for the right, but I didn't want to complicate the diagram. So I need to remove my previous deployment and services first. And now how do I install the Ingress controller? I will be using Helm, though it's not necessary. It's just much more comfortable. So let's do this Helm install. And meanwhile, I can show you the values that are here. So let's have a look at the values. And those values are only relevant for Apache API 6. If you are using another Ingress controller, there will be different set of values. It's just because I'm using the Helm chart. The most important value is, of course, Ingress controller enabled equals true. You see, however, that Ingress controller relies on a service of type not port. That's very, very important. So far, we have seen different kind of like objects. We have seen service. We have seen load balancer, which are two different kind of objects. Now we are building, or not we, but Kubernetes builds upon something that is existing, which is the not port. So now everything has been installed. Here, as I mentioned, I have a left deployment with one replica, with one pod, same Nginx. Now the configuration will be a bit different. Configuration will be like if I ping, if I access this pod, it will return me left. And likewise, I have a deployment called right with the exact same opposite configuration. It will return me right. And here, I don't want to delve deeper at this moment. So let's make sure that everything works as expected. We have got all the service so far, and you see there are a couple of them. So some of them I already described. So here, this is etcd. This is not important for our purpose. It's just that API 6 relies on etcd for its internal configuration. So we have etcd stuff, like dedicated one, not the one used by Kubernetes. But here is the one we are interested in, like Apache API 6 Ingress controller. And as we can see, it has a dedicated IP, and also API 6 admin has a dedicated IP. So here at this moment, we leave the demo because there are lots of different things to say and it's not feasible. So the first thing we can do is apply the Ingress. And we rely on a dedicated Ingress controller. The first thing to note at this point is that there is no URL rewrites. So if I'm pinging /left, it's okay. If I want to do /left/something, /left/something will be forwarded to the pod and to Nginx because it's an Nginx pod. And if we didn't configure /left/something, but just /something, well, we will have a 4.4. So that's the thing. We can rewrite depending on the implementation. And here is the implementation for Apache API 6. And we can do it through annotation. But you will note that those rewrites are not portable. So if a rewrite is portable regarding the implementation of the Ingress controller, like so if the rewrite is possible regarding the implementation of the Ingress controller, it will need to be changed if you want to change your implementation. And that defeats the purpose of a specification, that you have one single specification, and if you want to change your implementation, it should be close to a no-brainer. So here, it's not possible. The thing is, most of the time you want to version your APIs or your apps or whatever. And there are a couple of versioning schemes. The first one is path-based. This is what we could be doing by using like our routing by path. The other is query-based, and the third one is header-based. At the moment, the Ingress is only path-based. So you cannot have two versions of your application in a pod and say, okay, I want to version them through headers. You need to use path-based routing. This is a severe limitation, in my opinion. And finally, we can bypass those two limitations by not using regular configuration of the routes in the Ingress. So here you can see I'm using the configuration of the Ingress, but I want to bypass those limitations. So depending on your implementation, you might have custom CRDs, and you probably have. So here I'm using the one for Apache API 6 called API 6 routes. And now I can finally do query-based routing. I can finally do rewriting, and it works. But notice how we moves from, we have one Ingress controller implementation that can do whatever we want, and we can change to another implementation to, oh, okay, if we want to have easily migrable configuration, we need to rely only on a very specific subset of the features, which are the features offered by the specification, and they are very, very limited. Finally, the last limitation is that if you use the Ingress object directly, I need to configure everything under the Ingress object. Meaning that if we have different teams working on the same Kubernetes cluster, then at some point they will need to write on the same manifest. And, well, it's going to be a mess from an organizational point of view. I'm pretty sure that at some point, some of the configuration will be erased by another team, or it will be blocked, or it's going to be a mess. So that 3 reasons not to use the Ingress object, but to use the implementation specific configuration, which makes the specification quite smooth. So we need to be better. We need another way to do that. And that's the idea behind the Gateway API. The Gateway API tries to improve upon the previous limitation of the Ingress controller. So first, it splits the gateway itself and the routes, meaning that you can have a gateway object handled by, I don't know, the Kubernetes admin, and then you can have different routes and configuration files handled by each team. Then we can do HTTP header manipulation and much, much more. So again, the idea is that the Gateway API was designed to solve most of Ingress issues. Let's try to do some query-based routing, and look, we have the idea of HTTP routes, no custom CRD, so it looks very, very similar to the API 6 route before, but now it's under the Kubernetes namespace. Just note that at the moment, you need to install those specifically, explicitly, because they are not part of the Kubernetes distribution, because it's experimental. But finally, it will get there, so you won't need any extra install. And likewise, you can have query-based routing, which should work out of the box. And finally, you have routing with rewrite. So all the problems we have seen before, they are solved by the API gateway. So all problems that we have seen before, they are solved by the gateway API, this new gateway object. And there are plenty and plenty of implementations available. But of course, it's not all roses and rainbows. There are a couple of issues. The first thing is, depending on the exact version that you want to use, the rewriter is not available. For example, at the moment with Apache API 6, it uses the CRD version 0.5, but the rewriter is part of a higher version, so it's not available. Depending on the implementation as well, there might be other issues. For example, Apache API 6, we are not using gateway class nor gateway, which allows you to have different gateway implementation. So there is one single one, you need to use this one. So all of those implementers, they have they are at different stage of implementations. Most important, the specification is still evolving and it's still experimental, meaning that what works right now might not work in a couple of weeks. Even worse, the implementation themselves, they are evolving and they are trying to chase the specification. So, as I mentioned, there are many different implementations available. They are all at different stages of implementation. And depending on the implementation, there might be bugs. I mentioned that the Gateway API solves all the three problems that I've mentioned to you before. That's great. But I'm pretty sure that there are limitations that we didn't get yet because we were stuck on the Ingress controller that we need to solve and that the Gateway API doesn't solve. I don't know, perhaps you want to do monitoring because, well, everything needs to be monitored inside. You might want to do stuff that your regular implementation allows you to, but that the Gateway API doesn't allow you to. So at this point, we are still trying to discover what are the limits. I have been working in Java before, and at the time there was something called Java EE. Now it has been renamed to Jakarta EE. The idea was to have one single implementation and, one single specification and to have different implementations that were on the application server side. You would have a Java EE server, and then you would have, I don't know, like WebLogic, and you could replace it with WebSphere because both were like certified to be Java EE compliant. The thing is, yes, it worked, but the vendors made it very, very easy to provide stuff that were outside the bounds of the specification. Probably not because they wanted to lock you in, although that was a nice side effect, but just to make it your life easier. It was very easy to fall into this trap. Like, we want to have something that is like easily migratable from one implementation to the other. So you are using a Java EE server, but then when we start using it, then we use something that is outside the specification, something that is vendor specific, and that locks you in. So the idea of having one implementation, one specification and many implementation looks very, very nice on the paper, but in reality, all vendors provide like specific stuff because, well, the specification has limits. Like in the Ingress controller, we have seen that if you want to use the Ingress object, it's pretty limited. So if you are using Apache API 6, for example, then it's very easy to use the Apache routes, the API 6 route that allows you to do some configuration. And at this point, you are stuck in the implementation. So be careful. You should be very, very wary of that. At the moment, the Gateway API should be on your radar because it's the latest stage in the like accessing your pods from outside the cluster. But however, it doesn't solve every problem. So we are waiting for the next object. Thanks for your attention. You can find me on Twitter. You can find me on Mastodon. If you are interested in the code that I've shown you, everything is available on GitHub. And if I got you interested in Apache API 6, just have a look. Thanks a lot and have a good day.